Hello my dear students, welcome back to NEET World. So we will be continuing our discussion on IUPAC nomenclature. Along with that, today we will be discussing isomerism. Okay, so now we need to discuss few more things about IUPAC nomenclature when it comes to cyclic compound. Okay, for example, here I am writing like this. So what is the name of this compound, you tell me first of all? What is the functional group here we have? Like keto group. So what is the cyclic, like how much ring size here we have? One, like see, 1, 2, 3, 4, 5, 6. So cyclohexane, if it is alkene, here double bond O is there now, so that is ketone. What is the suffix we should use? On. Cyclohexanone. Okay, like this. Now what if I have structure something like this? So now our CHO group is an aldehyde which is present out of the ring, right? Now it is not counted in the ring. So our ring size is how much? 6, and carbol, like this aldehyde group, is out of the ring. So now in this case you should follow this method. See, when some carbon containing functional groups are directly attached to the ring, something like that. Okay, the ring is taken as parent chain. What is the parent chain here? Ring is parent chain, and a special suffix is used for these functional groups. For example, here I have CHO group now. I should call it as carbaldehyde. What I should call? See the name carb. Why it is carbaldehyde? The carbon of this aldehyde is not counted in the parent chain right now. Therefore, it should be specifically named as a carbaldehyde. Okay. For aldehydes it is carbaldehyde. For carboxylic acid like COOH, you should call it as carboxylic acid. For carbonyl halides, it should be carbonyl halide. Okay, SL halides, like that if you present. Okay, next esters, you should call it as alkyl carboxylate. What is the name? Alkyl carboxylate. Okay, and for amides you should call it as carboxymide. What is that? Carboxymide. And for nitriles you should call it as carbonitriles. What is that? Carbonitrile. Here tell me, what is the name of this compound now? Cyclohexane. Cyclohexane, you can pronounce it properly. Cyclohexane carbaldehyde. Okay. Okay, next. Answer these questions now, tell me. What is the name? Just now we have written. Cyclohexane carbaldehyde. And what about this?
Sir, but it is inside the chain.
See, this is cyclohexane parent chain and it is a substituent now, aldehyde. Now for this, what I told you, for amides, carboxymide. So it means, tell me, cyclohexane carboxymide. That's it. Cyclohexane carboxymide. So just note down this first. This table is important here. Okay, so there is a JEE main question previously asked from this table itself. Kalyan, good evening. Yes. Yeah, it's really great you are joining without missing the class every day. Right, next. Let us move forward. So now answer this one. Cyclohexane carboxylic acid. Cyclohexane carboxylic acid. Now what about that?
Cyclohexane methyl carboxylate.
So first write the name of this methyl group. Methyl cyclohexane carboxylate. Next, what about this compound here?
It's a benzene.
Yeah, so benzene ring is there now. So if on benzene ring only one halogen is present, like halogens are present, always call halogen as a, take it as a prefix, like halobenzene, bromobenzene, chlorobenzene. Like if two bromines are there, dibromobenzene. If one chlorine, one bromine is there, follow IUP alphabetical order. Okay, which comes first? B comes first. So bromo, chloro, benzene by mentioning their positions. Now tell me for this.
Ortho, bromo.
No, I am not asking you ortho para here, because ortho para, to be frank, they are not IUPAC. They are comes under common names. Okay, now tell me here.
4 bromo.
Which, like you need to number it in such a way to give lowest number possible. See, I am starting numbering from chlorine. Why from chlorine? Because 1 if I give here, 1, 2, 3, 4, 5 we will get. So you will be getting numbers as 1, 2, 3, 5. In any other manner you try, you will get either these numbers as it is or bigger than this right now. So why I am only starting from chlorine, why not from iodine? C comes first now, so I am starting from C, chlorine. Okay, now tell me, now while writing the name you should follow alphabetical order. So tell me the alphabetical order.
2 bromo, 1 chloro.
So 2 bromo, 1 chloro,
5 fluoro,
5 fluoro,
3 iodo,
3 iodo, benzene. Is this clear? Again, 2 bromo, 1 chloro, 5 fluoro, 3 iodo, benzene. That's it. Next, what about this compound?
benzoic acid.
On benzene ring, if we have carboxylic acid, we might think like benzene carboxylic acid, but we can call it as benzoic acid. Okay. Now if there is any methyl group here, what we will call now?
Methyl benzoic.
What is the position? 3 methyl benzoic acid. And for example here I have one chlorine, 4 chloro, 3 methyl benzoic acid.
So first we should consider halide, then methyl.
Alphabetical order. For substituents, if we have multiple substituents, alphabetical order, that's it. Okay, but numbering should start from principal functional group. Next, what about this? For example here, tell me for this one, you tell me. Methoxy group is there. Okay, whenever on benzene ring methoxy group is there, you can say methoxybenzene first. Okay, so one more name, the common name of this compound is anisole. What is that? What is the common name? Anisole. Methoxybenzene is considered as anisole. You can remember this. Okay, right. See, on benzene ring if you have OH, on phenyl ring if you have OH, you should call it as phenol. Okay, so now if this phenyl group is having, phenol is having some chlorine here. 2 chlorophenol. And here I have methyl.
2 chloro,
3 methyl phenol. If I have nitro group here,
3 chloro,
2 chloro, 3 methyl, 4 nitro phenol. Next, this one, methyl benzene, we can call the common name as toluene.
Toluene is not an IUPAC name.
No. Okay, but it is considered. Okay, next.
Benzenamine or aniline.
On benzene ring, if we have amine group, we can call it as benzenamine, and its common name is aniline. Okay, right. You should ask me a question now, sir. On a benzene ring, if we have OH group and NH2 group, what we can call it as? Whether phenol or whether aniline? As per IUPAC priority order, which comes first? OH group is more priority. Okay, it means you should give your name according to the priority. Like I can say phenol, it's a derivative of phenol. What we can say? 3-amino phenol. Like that. Next, write the name of this compound.
Trinitro, 2, 4, 5 dinitro
2,
phenol,
4, 6 2 comma 4 comma 6 trinitrophenol. Okay, and you know there is a common name for these as picric acid. What is that? Picric acid. Okay, picric acid. So you know this picric acid is highly acidic. Why? Because see, phenol is having what groups now? Electron withdrawing groups. I will explain about that. So due to that presence of that groups, it making it to be more acidic. Now what about the name of these compounds? Tell me. How can you write the name for this? See, what is the functional group here we have? Carboxylic acid group is there. To this carboxylic acid group, there is a substituent now. What is the substituent name?
Benzene.
You should not say benzene, you should call it as phenyl. What is that?
Phenyl carboxylate.
Phenyl.
Carboxylic acid.
See, you can start numbering from carboxylic acid carbon. 1, 2. 2 phenyl.
Carboxylate.
2 phenyl. Substituent is over. How many carbons are there? 2. So ethanoic, 2 phenyl ethanoic acid. See, always like it's not mandatory to represent number 1. Okay, you can ignore that 1. Okay, so 2 phenyl ethanoic acid. Is this clear or not? Right. Next, here try these names. Don't look at these names first. We'll reveal it once if you practice them. Try them.
Four ketone, 2 hydroxy, pentanoic.
Which is priority functional group here? COH. So numbering from there it is proper way. And in the parent chain we have ketone, one functional group carbon is also included. So when functional ketone carbon is also included in the parent chain, you should call it as oxo. What you should call? If it is ignored from the parent chain, that should be keto. If it is not in the parent chain, you can call keto, specifically mentioned. Okay, now tell me.
4-oxo.
So 4-oxo,
2-hydroxy,
pentanoic acid. 4 like based on alphabetical order again. Which comes first? H comes first now. So 2-hydroxy, 4-oxo. See, if you fix the principal functional group, all other functional groups becomes substituents only. There is no priority next. Okay, first you fix one principal functional group, then all other functional group becomes substituents. So follow their alphabetical order, like 2-hydroxy because H comes first. Okay, now next what about this?
Cyclohexane
Carboxylic acid. Already we did this. Next what about this? Look here, like aldehyde. If I start number from here to here, we'll get longest carbon chain, but this is missing now. So you should not number it like that. You just give your numbering to this alkyl chain. Then you can call this as carbaldehydes. So yeah, we are not counting now, so you can call it as carbaldehyde. So 1, 2, 3. Anyways, you can go from here or here same. So what is the name? Propane 1, 2, 3 tricarbaldehyde. How many carbaldehydes are there? 3. So you can write 1, 2, 3 carbaldehyde. Okay, so there is a question in PYQs similar to this. You can practice those. Yes, the chart box, it's really going well. Let's see few more questions. Now answer this question. We already tried this model. Yes, tell me. Fast. Which is priority functional group? OH. So that will be called as phenol now.
3 with
from
3 with
Even if I come from here, it is 3. Even if I come from 3 here also. But A comes first now. So 3 amino, 5 methyl, 5 methyl,
phenol.
3 amino, 5 methyl phenol is perfect. Okay, right. Next, what is the functional group priority?
COOH,
COOH, sulfonic acid next,
CN,
nitrile,
CHOOH.
perfect. Next. Answer this question. IUPAC name of the following compound is?
4, 5, 6, 7.
Out of these two functional groups, which is more prioritized?
CN.
CN. So number from here 1, 2, 3, 4, 5, 6.
5
So,
oxohexane.
5 oxohexane nitrile. 5 oxohexane nitrile. That's it.
One isoprene.
Isoprene. What is this isoprene means? This is what? Cyclobutadiene. Okay, and not cyclo, just butadiene. 1 comma, see 1, 2, 3, 4. So you have 1 comma 3 butadiene. This is normal. Now if I insert one methyl group over second position, we can call it as isoprene. What is it? Isoprene. So this its IUPAC name you can answer no?
1 comma 3, sorry, 2 methyl.
2 methyl.
Buta 1 comma 3 diene.
2 methyl 1 comma 3 butadiene. So option C is there now. That will be our answer, right? Next, answer this question.
IUPAC name of compound F. NO2 is first prioritized. Nitrobenzene. 3 ethyl, 6 fluoro, 1 nitrobenzene.
See, just all this fluoro, nitro, ethyl, all these are substituents only. They should be given as prefixes only. Okay, there is no suffix means. You follow alphabetical order while writing the name. Okay, but while giving the numbering, follow least locale rule. So it means I can start from here. If I start from here, 1, 2, 3, 4, 5 will get in. So what are the substituents? 1, 2, 4. If I start from here, 1, 2, 3, 4, 5. So 1 comma 2 comma 5. So first way is better na. So it means F, N, E. Which comes first? Ethyl. E comes first. So 4 ethyl, 1 fluoro, 2 nitro, benzene. Next. Can you try this? Fast.
6 bromo, 2 chloro.
From where I should start numbering?
That side.
This side?
No, that side.
This side? 1, 2, 3, 4, 5, 6. Tell me.
6 bromo.
6
2
bromo,
chloro,
2 chloro, 3 methyl,
hexane for all.
hexane for all. So
First one.
that's it. Next, a compound with molecular formula C6H14 has 2 tertiary carbons. What is its IUPAC name? So what do we mean by primary, secondary, tertiary carbons means?
3 different groups,
Ah.
methyl groups.
So to the carbon, if this is a carbon having one methyl group, now I can say this carbon has one, see, to this carbon how many carbons are directly attached? 1. So primary. To that carbon, if 2 carbons attached, secondary. If 3 carbons attached, tertiary. So now they are saying tertiary. So 2 tertiary carbons means definitely it should be like this.
Dimethyl butane.
Tell me. 2 comma 2.
Dimethyl
See.
butane.
1, 2.
Sorry.
See.
2 comma 2 dimethyl butane.
See. 6 carbons we required now. So first put 2 carbons. Make it tertiary. How many over? 2 this side. 2 this side. 4 over
6.
5, 6. Okay, now by making a bond here it becomes
dimethyl butane.
2 comma 3 dimethyl butane, that's it. This one fast.
2, 6, 4.
The structure of 2 comma 6 dimethyl dec 4-ene.
Fourth one.
We'll go from here, okay. Dec 4-ene means, okay, we'll start from 4 only. 1, 2, 3, 4, 5, 6. Okay, 2 comma 6. Right. You can try these questions. Okay, next we'll move forward for isomerism. So tell me, what do we mean by isomers and isomerism means? Isomers are those compounds having same molecular formula, but they might be differ in their structure. If they differ in their structure, we should call it as structural isomers. But there are some compounds having same structure, but the three-dimensional arrangement of atoms will be different. Then that will be considered as stereoisomers. Okay. Now structural isomers are this many types. Like chain isomer, it means some isomers are there, like formulas are there, they are just differing in the parent chain, considered as
Chain isomer.
some are differing in the position of this functional group or substituents, okay, or ring chain isomer. Some compounds are in ring, some are in open chain, okay. And functional group isomers means they differ in their functional group attached, okay. Metamerism means I will tell you, tautomerism means again we will discuss now, okay, right. So stereoisomerism again classified into two types, configurational, conformational, okay. So now what do we mean by conformational isomers? For example, if this is a carbon-carbon bond, here we have two carbon-carbons. Now by rotation of small angle here, whatever may be, small or bigger angle, by rotation in this angle, what it is making? It is giving a new pose, right now. So those all new poses which are formed by rotation of this CC sigma bond are considered as conformation of that molecule. We will discuss clearly, okay. Next, here structural isomers are also called as configurational isomer, constitutional isomers. What I am saying? Constitutional isomers, okay, right. So for best example for the stereoisomers, I will tell you, look at this. C double bond C, here we have if you observe the structure, this structure 1, structure 2, how do they differ 1 and 2? See, this carbon is attached to one more double bond carbon, sp2 carbon, and this side if you see methyl group and hydrogen. Similar same story here also, hydrogen methyl group is attached to the sp2 hybridized carbon. Everything is looking same, but their spatial orientation they are differ right now. So methyl group is above side, here it is below side. It means two methyl groups are of same side here, two methyl groups are opposite side here. So we can call these two as geometrical isomers, or I can say stereoisomers. What is that? Stereoisomers. Similarly, we have one more term called optical isomers. We will discuss that after knowing few the other things. Okay, right. First of all, what do we mean by chain isomers? Tell me.
Same molecular formula but different structure.
Same molecular formula. Compounds having same molecular formula but differ in the carbon skeleton. So example C5H12 means what is it? Alkane or alkene?
Alkane. CnH2.
So this is N-butane, N-pentane I can say. Writing like this. Isopentane. How do they differ? They differ in their differ in their parent chain. Chain having 5-member long parent chain, here it is having only 4. So if they differ in the parent chain, I can say carbon skeleton, it is differ now. So it is
Chain isomer.
chain isomer. Next,
Pentane.
positional isomers. Now you can say isomers which are differ in the position of branch or substituents are considered as a positional isomer. For example, C4H8. Tell me alkane or alkene it is?
Alkane.
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 Alkene. See, CnH2n.
Mine. Yes.
Yes. So I can write alkene as one alkene or this two alkene.
Is it
One
possible?
butene, two butene.
Other with alkenes, is it possible positional isomerism?
It is possible.
How?
This is
alkane.
yes, with alkanes also it is possible. For example, I mean haloalkanes I am taking now. See, I am taking C5H11Cl. What is it now, alkene or alkane?
Alkane.
CnH2n plus 2. Okay. So now 5 carbons over. Chlorine I am writing at this terminal side. Writing this second position. So how do they differ? They differ in the position of chlorine.
Some difference between functional and positional.
Uh-huh.
Functional and
Functional will go to there. Wait. This is not. This is positional isomers. Okay. So they differ in the position of chlorine now. What is the position of chlorine here?
2,
Here it is.
1.
So these are positional isomers. Okay. Next. Functional isomers means isomers which are having same molecular formula but differ in their functional group. Example, aldehydes and ketones. Ketones. Example will write, see aldehyde means CH3, CH2, COH I am writing. Is this an aldehyde or not? Yeah. Write a ketone with the same formula.
CH3,
CH3, C double bond O, CH3. Here acetone and propanaldehyde are functional group isomers. Because it is an aldehyde functional group, it is a ketone. Okay. Similarly, we can get alcohols and ethers. Give an example for alcohol. 1, 2, 3. So propanol I have written, and with the same molecular formula I am writing CH3O C2H5. So this is an ether, this is an alcohol.
Methyl.
Okay. Methyl, ethyl, ether we can say,
Methyl.
or we can say methoxy ethane. Okay. Next, you know, primary, secondary, tertiary amines will be there now. Those are also comes under functional group isomers. So how do they differ? CH3, CH2, 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 NH2 I am writing. So what is the degree of this amine? To the nitrogen, how many alkyls carbons are attached? Alkyl groups are attached? 1. So you can say primary. Next, how many 4 carbons are there now? So we'll make CH3, CH2, NH, CH2, CH3. Tell me here. Ethyl, ethyl. Secondary. 2 alkyl groups attached. Now I am making it CH3, CH3, C2H5. How many carbons attached to the nitrogen? 3. So it should be considered as tertiary. You got 3 different forms. So these are what? Functional group isomers. Okay. Next, ring chain isomers means one isomer will be in ring form and another one will be in aliphatic chain. Okay, for example, we have C6H12. Tell me alkene, alkane or alkyne?
Alkene.
Okay. See, why I am always asking to identify alkene, alkane or alkyne? We get to know its degree of unsaturation. What do we mean by degree of unsaturation?
Number of double bonds.
Number of pi bonds possible in that structure. Okay, so for example C6H12 means it is a general formula for alkene. Right now alkenes have how many double bonds, how many pi bonds? Like this kind of formula containing alkenes will be having one pi bond right now. So it means this formula definitely having one pi bond. I can represent with the same formula, I can represent as a cyclohexane also. Cyclohexane means how many carbons here? 6 carbons, C6, and each carbon is having 2 hydrogens. Like this, the closer chain
C6H6.
1, 2, 3, 4, 5, 6, or I can write an open chain something like this. It is also having same formula. So one is closed ring and one is open chain. So considered as ring chain isomers. Okay, ring chain isomers are also functional group isomers. Yes, because this is an because this is an alkene, cycloalkene, cyclohexane, but this is normal alkene. So ring chain isomers are also functional group isomers. Okay, now what about metamers means? See, compounds having same nature of functional group but different nature of alkyl groups along the functional group. I mean, for example, taking ethers, CH2, CH3, CH2, CH3. So both sides we have ethyl group now, ethyl group as a functional group. Now what I am making here, now how do they differ?
Ethyl propane, ethoxy propane.
To this oxygen, both sides ethyl groups only, but to this oxygen one side methyl, another side is propyl. So how do the both compounds are differ? Both of them are having same functional groups, compounds having same nature of functional groups, right, same functional group, but different nature of alkyl groups attached. Here alkyl groups are ethyls, but here it is ethyl and propyl and methyl.
Is it possible for ketones?
Yes, ketones also possible. So you can put second position, third position, what happens?
R group is
Yeah, next.
for aldehydes is it possible?
No, for aldehydes it won't be possible. Why it won't be possible?
But it is only the terminals.
Yeah, because one side it is fixed as H, so it won't be, right? Next. One more important topic here is tautomerism. See, what do we mean by tautomerism? See, it's a phenomenon by which a single compound can exist in 2 or more interconvertible structures. They are differ in relative position of at least one atomic nucleus, generally hydrogen atom. It means you just look at here what I am writing, X, Y, Z. On this X I have one atom like hydrogen. So number it 1, 2, 3.
Reverse. One. You said they should have one.
Anyways, see 1, 3 proton transferring is taking place here. See what happened is, what is the valency of X here? How many bonds are there?
One sigma.
2 bonds are there, 2 sigma bonds are there. It means it is having 2 bonds in total. So now the valency of any atom should not be violated here. See, for this X and Y double bond will be shifting between X, from Z to X and Y. So this hydrogen is going to this
X
Z.
double bond Y,
X
Z
double bond Y, Z, H. So what we have seen here, 1, 3 proton is transferred.
Sir, here X, Y, Z are 3 different compounds.
See, if you want, you can take them, consider here, C double bond O, CH3, H. So now I am writing numbers like this, something like 1, 2, 3 is numbered. So out of these 3 protons, writing CH2 and 1 H like this. So tell me 1, 3 I told now. So
it will become alcohol.
yeah. So now tell me what I can write.
CH2 double bond C. OH.
See, here I can also represent this one in a more proper way if you want. See, I am using a word proton transfer right now, hydrogen transfer or proton transfer. So in order to transfer proton, this this sigma bond will be shifting here. It will be becoming negative here on Z and H place, making a bond. Here also you can see like this, and oxygen is more electronegative, take the pi bond. Okay, it depends purely on their electronegativity difference. CH2, here sigma bond becoming a pi bond. O, H, H. So this is aldehyde form now.
Yes.
And this is what? Enol form.
Enol.
Like something like if it is a ketone, enol forms are obtained here. That's it. Okay, next. So now conditions for tautomerism. What is the condition? At least one hydrogen on the sp3 hybridized alpha carbon. What carbon? Alpha carbon. So why only alpha carbon? You can take anything. See, I am taking here imine group I am taking.
Imine.
What is this? Imine. Okay. One hydrogen. See, the nitrogen attached carbon is alpha. To this imine group carbon, the next carbon is called alpha. So alpha hydrogen is there now. Or you can, if you are getting confused, you can number it as 1, 2, 3. Which is the electronegative atom here?
NH.
Nitrogen atom here. So it will take the pi bond. So if it is taking pi bond, what is the charge creating on the nitrogen?
Negative.
And this carbon?
Positive.
So in order to satisfy the valency of the carbon, hydrogen is, sigma bond of hydrogen is donated. Like this. So I can say, here it is imine, converting into, see here we have double bond, in, and this is amine. Enamine tautomerism is taking place here. What is the primary condition here we have seen? Alpha hydrogen. Okay. Now, sir, you are saying keto-enol tautomerism, but tell me whether a compound exists in more keto form or enol form. How can we decide? It depends on some factors like solvent. If solvent is more polar, that will be having less enol content. What I am saying?
Solvent is less polar.
Solvent is more polar,
Less enol.
less enol content. It means in non-polar solvent,
No.
tell me whether keto form or enol form, which is dominating?
Non-polar.
Enol form will be dominating. Okay? And in polar solvent, keto form will be dominating. You can remember this relation. Okay. So now, what are the factors, other factors we have for making enol form? See, you can observe this. Like this it is given. Tell me keto form or enol form it is? Keto form. So now 1, 2, 3. So here we have alpha hydrogens now. So tautomerism is taking place to convert into enol form. So we can call this enol as a phenol specifically in this structure. Okay, now tell me equilibrium shifts which side? Forward, because respective compound here formed is aromatic. from a non-aromatic compound, from a less stable compound, more stable aromatic species is obtained, therefore equilibrium moves forward. Okay, so similar to this, tell me here tautomerism takes place or not?
No.
Why no?
No alpha hydrogen.
See, it's not specifically alpha hydrogen means here only. See, I have a hydrogen here. If this pi bond is shifting towards oxygen, now pi electrons will move here. So where do we see in the positive charge?
But it is
Here.
mentioned alpha hydrogen. It is
Alpha with respect to this conjugative double bond you can consider. So here you are seeing a positive charge. To that this proton is giving its sigma bond electron. So what will be having? Here it is shifted, it is becoming O minus H. Here also phenol. Okay, they will ask by giving 4 structures, which are the following
Shows
tautomerism, or which are the following having highest enol content, or which are the following does not show tautomerism. These are the general questions from this topic. So look at here, what are the factors I told you? First one is aromatic. If the respective enol formed is aromatic, then that will be having most enol content. Okay, and then next here we can see dicarbonyl compounds. What do we mean by dicarbonyl compounds? See, again specifically beta dicarbonyl. It means CO, CH2, CO, R group here, and some R dash group here. See, alpha, beta. With respect to this, if I say this is alpha, beta carbon now, so beta carbonyl, dicarbonyl compounds I can say. So now what happens, you know, whenever there is a methylene group, this is CH2 group is called methylene group, flanked between 2 keto groups or 2 carbonyl groups is acidic. What I am saying?
acidic.
So if I give this methyl group here and I am asking you which hydrogen is more acidic?
alpha hydrogen.
Hydrogen which is flanked between 2 keto groups or carbonyl groups is considered as more acidic. Why? Because respect to conjugate base is highly stable. Why highly stable? Check here. If I write it like this, the negative charge formed here can be stabilized like this. Okay, that we will discuss in the resonance concept. Anyways, here if I shift this proton like 1, 2, 3, either this side or that side, okay, depending upon electron deficiency we need to consider. Okay, so now I am shifting towards this, it means it becomes OH and this becomes double bond. After forming this, see, we have oxygen atom having pi electrons, means partial negative charge here. What about this? Partial negative charge on oxygen, partial positive charge on hydrogen. So now there will be
Hydrogen.
electrostatic interaction, that is nothing but hydrogen bond. What is the ring size formed due to hydrogen bond? 1, 2, 3, 4, 5, 6. Whenever there is a 5 or 6 membered cyclic ring is formed because of hydrogen bond, that ring is more stable. So it means it is stabilized by what? Hydrogen bond, by formation of 6 membered ring. Okay, this is what you need to understand here. And next thing,
Alpha dicarbonyl.
next one more thing here, in this beta dicarbonyl compounds I have mentioned one side keto group and the other side aldehyde. Tell me which side enol formation takes place, 1 or 2, which side it will be converts?
2.
No, aldehyde carbon is more electron deficient, therefore it will drag the sigma bond electrons towards itself, therefore converts easily into enol form. So which one? This aldehyde carbon will be converting into enol form. You can understand it in that way. So you can write CH3 COCH double bond COH H. this interaction. Next, alpha dicarbonyl means like adjacent it should be. Like this. So whenever we have this kind of open chain structures, due to repulsions between the pi electrons of these two oxygens, one will be lies above the plane, one will be lies below the plane, because here CC bond rotation takes place now, so it becomes C double bond O like this. So it means for alpha dicarbonyls, which form is greater, enol form or keto form? Keto form only, because they are in different planes. Okay. Now tell me here, this is alpha dicarbonyl or beta dicarbonyl? Alpha dicarbonyl. Adjacent carbon only, no? Alpha dicarbonyl. But it is a locked one. It is an open one. It has rotation. Therefore, in order to avoid this repulsion, it has a rotation. The CC bond rotation takes place, and one carbonyl groups goes different plane. Therefore, they can avoid repulsions. But here, if you observe, due to this locked system, there will be high repulsions between both oxygen atoms right now. So what is the possibility we have to avoid that repulsions?
Remove cleavage of bond.
Yeah, it means compound won't won't be cleaved here.
Hydrogen.
Yes, see here adjacent to this, here we have alpha hydrogens now, or to this we have two alpha hydrogens now both sides. So one of this keto group, one of this carbonyl group converts into respective enol form. So let's convert that. So if you convert these hydrogen to enol form, double bond here. See, we got a hydrogen bonding interaction again. What is the cyclic ring formed? 1, 2, 3, 4, 5. So what I told you, 5-member, 6-member ring formed by hydrogen bondings are highly stable.
Then it should be more stable than alpha.
Yes. Yeah, that is what I am saying. That is what our conclusion here. So whenever cyclic alpha dicarbonyls are there, enol form will be major than this keto forms. Why? Because the cyclic alpha dicarbonyl compounds are stabilized by hydrogen bonding. That is not possible in open chain. Okay, is this clear?
Sir, but
Yes, tell me.
we give that general order of enol percentage has beta equal.
I mean, I am comparing open chain, closed chain. Okay, so you need to follow this order. If you want to compare,
So what if beta dicarbonyl is open chain and alpha dicarbonyl is closed chain, which is more enol percentage?
it depends on specific compound again. Okay, next monocarbonyl means that is the simple one we have taken now. Ketone or aldehyde you can take, that will be your monocarbonyl. Already we have studied about this keto enol forms. Okay, next. Answer this question. Which of the following does not show tautomerism? What is the primary condition?
Alpha hydrogen.
Alpha hydrogen to the carbonyl groups. See, write the structure for more clarity. This side we have phenyl group, keep it aside. This side we have CH3 group. Try to understand the structure what they have given. So do we have alpha hydrogens? Yes, these are alpha hydrogens, so it shows tautomerism. Next, what about this structure?
Yes.
CH3 is there now,
CH3 has 3 alpha hydrogens.
so it can also show tautomerism. Okay, now what about this? Yes, acetone, that is also having both sides CH3 groups, it is also shows tautomerism. Next, what about this?
Phenol.
One side is phenyl, not phenol, it is phenyl, and other side is trimethyl or tertiary butyl is attached. See, do we have any alpha hydrogen? See, this is alpha carbon, we have beta hydrogens but not alpha hydrogens. If no alpha hydrogens, no tautomerism. So phenyl ring doesn't have any alpha hydrogen, that won't show. So option C will be, option 4 will be perfect answer for this particular question.
Sir, how will phenolic does not have
Huh?
C triple? Yes.
Okay, next. Number of structural isomers possible for C4H8. Will you try this? Okay, you can try this question. Discuss in the next class.
So which type of isomers?
All possible, structural. Mention na, like you can try to find its positional, chain, functional, whatever. All structural isomers that we have studied till now. Okay, that not geometrical. I am saying only structural. Yeah, find this. How do they differ? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. But position of methyl group is different. So we can say
Position isomer.
positional isomer. Next, what about this? Both of them having how many pi bonds we have in the structure? Pi bonds, I am asking, pi bonds, 2. Here also how many pi bonds? 2. So it means its degree of unsaturation is 2. It means the molecular formula will be same. But this is an alkyne, this is alkene.
So functional isomer.
So they are functional isomers. Clear now? Right. Next.
Sir, but tautomerism is possible for them.
Here, yeah, it is possible, but we are not discussing about tautomerism here.
Or the
In this. What about this question?
which are the molecules of compounds are not metamers. Ethers are
Yes, this is ether, this is also ether, differ in alkyl groups. So these are metamers. They are asking here ethyl,
Yes, it is a metamer.
it is also metamer. Okay, this is nitrogen, secondary nitrogen, this is also secondary nitrogen, different alkyl groups. Okay, next this one, check once. NH,
Same alkyl groups. CH3, CH3.
this which one?
Fourth one.
Which of the following are not metamers? Let's see. So this is metamers only. Next option we'll see ethyl group. Next here methyl and this one CH, CH3. So these are also metamers. But how many carbons are there? 2 plus 2, 4. This is also metamers. Next here CH3, NH, and this side propyl, and this one
It is also
ethyl, NH, ethyl. Next here last one we can cross verify again, CH3, NH, propyl. This one CH3, NH. This side CH, CH3, CH3.
Sir, methyl are same, right, sir?
Yeah, so alkyl groups are not changed here. So we can say most appropriate one might be fourth one. Okay, that's it. I have given just one question. Remaining you can solve from module. Okay.